Hi, my name is Ellen and I'll be taking you through today's Saturday session. The subject we'll be looking at is junior cycle maths and our topic is functions. So what we'll be looking at today, I'm going to break the session down into 4 sections. What is a function, types of functions, interpreting functions and real life functions. Just before we get started, here's a few exam tips with regard to functions. The first one would be to know the basic concepts well. What is a function? What are the 3 types of function on the junior cycle course? How do you graph a function? And how can our calculators help us with this? Number 2, you need to attempt the question. So all questions carry attempt marks, so it is important that you try every question. And the third one, do your answers make sense? For example, if we were talking about a quadratic graph, which had a small rocket involved, if we knew the height of the small rocket after 1 second was 5 meters, and we could see that it was increasing, we know that the height of the rocket after 2.5 meters couldn't be less than 5. So just look at your answer and the context and see if it makes sense. We'll come back to this as we go through some examples. So let's think, what is a function? Well, if you think of a vending machine is a good example of a function. So what is the input? Well, what do we do that tells the vending machine what we want? For example, if you wanted the water, it's on the 4th row, and we'll go for the bottle here, the 3rd one in. So the 4th row in this case may be called D, and the 3rd row in may be called 3. That would be my input. That would be me telling the vending machine what I want. What is the function? Well, the vending machine is going to get its tray to move across to the water and move the whole way up so that it collects the water and brings it back down for us. What is the output? Well, at the out, we will have a bottle of water. And this will be coming out the end for us to collect. So these will be 3 key words you need to know with regards to functions. So the function is the rule that produces one output for each input. We can test this using a vertical line test. The domain, this is the set of inputs. So all of the inputs into the function. And the range, this is the set of outputs, everything we get out of our function. So what is a function? So think of a number, multiply it by 3, then add 2. If your input is 5, well, you'd think of 5, you'd multiply it by 3, that would give you 15, then add 2, your output would be 17. If we look at 7, it says multiply it by 3, 7 3s is 21, add 2, your output is 23. Again, if you look at your input as 10, 10 by 3 is 30, add 2, your output is 32. This function will be denoted as f of x is equal to 3x plus 2. Just a thing to note here, functions can be denoted by f of x, so where there's a bracket. They can also have f dot dot x and an arrow as well. Or this f of x can also be replaced by a y. Right, let's look at this example. So this would often be an A part of a question. It is giving you the input to put into your function. So for example, it says find f of 3. So we know that f of 3, that means our new input is 3. So everywhere there was an x in our function, we're going to replace that with 3. 7 3s, well, that's going to give me 21. Add 3, that gives you 24. Right. Another little example here to the side, I know it's called C, but we're just going to hit this one first, is f of 6. So 6 would be your input value here. So again, in our function, wherever we see x, we're going to substitute in 6. So you'll have 7 by 6, add 3. 7 6s is 42, add 3 is going to give you 45. Right, the next one then, it asks you to find f of k. This is where students start to get a bit confused. Reason being is people are used to dealing with numbers, and then when the letters come along, they freak out. So you just treat it the exact same way you would have treated your numbers above. So you're substituting in k. So everywhere you see x, you're replacing it with k. Seven multiplied by k, well that's 7k. And then we have add 3. Our last question then is a bit more difficult. So it says find k for which f of k is equal to f of 3. So if you see here, we've already dealt with f of k above, and we've already dealt with f of 3. So now what we're going to do is we're going to let our answers from above equal each other. So f of k equal f of 3. Well, my value for f of k, when I substituted in k, I got an answer of 7k plus 3. And when I substituted in 3, I got an answer of 24. Now I have a nice linear algebra question here. So remember with linear algebra, what you want is you want your letters on one side and your numbers on the other. So I'm going to keep my 7k on the left-hand side, and I'm going to bring my 3 to the opposite side. So we're taking 3 away from both sides. So 3 take away 3 is 0, and on this side we'll have 24 take away 3. So my 7k is going to equal 21. You think, how do I get k by itself? Well, we've 7 multiplied by k is equal to 21. So we're doing the inverse operation. So you're going to divide both sides by 7. 7 divided by 7 is 1. So k is going to give you 3. Now, here's a question very similar to the one we just finished there. I'd pause the video here maybe for 5 minutes, attempt it, and then press play when you return so you can see me go through the solution. Function is defined as f of x is equal to 4x minus 3, where x is an element of real. Find the value of f of 5. So our new input here is 5. So everywhere we had an x before, we're substituting in a 5. So 4 by 5 minus 3, which is 20 minus 3, which gives us 17. Right, part 2. It says write f of k and f of 2k minus 3 in terms of k. Again, this is where students start to worry. There's just letters here, so we're just replacing our input now with these letters. So f of k, again, our new input is k, so wherever we had x, we're just substituting in k. So we have 4 multiplied by k minus 3, which gives you 4k minus 3. Right, f of 2k minus 3 now. So everywhere we had our x, we're substituting in 2k minus 3. So 4 by 2k minus 3 minus 3. Now what we need to do here is we need to multiply out the bracket to get our final answer. So 4 by 2k will be 8k. 4 by minus 3 is minus 12, and we have minus 3. So our answer is 8k minus 15. Our final part then, it says, hence find the value of k for which f of k is equal to f of 2k minus 3. If a question says hence, it means use your answers from previous questions. So we looked and we found a value for f of k, and we've looked and found value for f of 2k minus 3 in the previous question. So now what we're going to do is we're going to let these equal each other and solve for k. So we have 4k minus 3, that was f of k from above, and we're going to let that equal 8k minus 15. That was f of 2k minus 3 from above. Now we have a linear algebra question, so we need to get our letters to one side and our numbers to the other. So if I get all of my letters over to the right hand side, so I have my 8k, I'm going to take away 4k from both sides. When I take away 4k from my left hand side, it's just going to go to 0, so we don't have to worry about it there. I'm going to leave my minus 3 on my left hand side, and I'm going to bring my 15 over. So I'm going to add 15 onto both sides. Again, when I add 15 onto this right hand side, well, minus 15 add 15 is 0, so it's been dealt with. Minus 3 add 15 gives us 12. 8k minus 4k is 4k. To find k by itself then, we need to divide by the number in front of k. So 12 divided by 4 So k is going to equal 3. So now let's recall on what a function is. So a function is a rule that produces one output for every input. So here's an example of a question from a mock below. So they've given us 4 graphs and it says, put a tick in the correct box to show that which of these graphs is not a function. Justify your answer. So when we looked at our keywords, we also gave a method for testing whether something is a function, and it was the vertical line test. So what this means is that if I draw a vertical line through all parts of my function, it should only hit it once. So let's try my first one here. So I draw a number of vertical lines through graph A. As you see, it only hits it once, so therefore that is a function. Now if I look at graph B, I'm drawing some lines through that. All my lines only hit the graph once, so therefore that is a function. Graph C, I draw a number of vertical lines through it. I can see that 2 of my lines hit the graph numerous times. So one line hits it on 3 occasions, and so does the other one. I just forgot to highlight it in the middle. So therefore that is not a function. Graph D then, let's just check. So my vertical lines, they hit the graph once, so therefore it's a function. Graph C is not a function. The reason it is not a function is that every input does not have a unique output. So here's a question similar to the one we just completed about knowing the definition of a function. So if you want to pause again, give it a go and then press play so you can check your answer. So the 3 curves A, B and C are shown in the diagram. 2 of the curves show a function of x. Please tick the one which does not show a function of x. Again, I'm just going to get my vertical line test through each of my curves. And it's clear to see straight away that it is curve C that is not a function, as my vertical lines in this case here are touching the curve at numerous points. If it was a function, all vertical lines should only touch the curve once. So your reason, each input does not have a unique output. So that's it for section 1, what is a function? What we're going to move on to now is looking at the different types of function. There are 3 types of functions that you can be asked to graph: linear, quadratic and exponential. A linear function does not have a squared term, it just has a singular x. So for example, f of x is equal to 3x plus 4. They create a line shape when graphed. Quadratic functions have a squared term in them. For example, f of x is equal to 2x squared add 4x add 2. They create a u, a positive x squared, or an n shaped when you have a negative x squared when graphed. So to remember this, we are positive when we are happy, so you have a smile. So a positive shape graph will be a u because it will be a happy graph. A negative x squared graph then will create a frown shape, an n shape. So that is just an easier way to remember if it is a positive quadratic graph or a negative quadratic function. Exponential functions then, they have a variable power, so 2 to the power of x. They create a shape similar to a ramp when graphed. So you'd often have our x-axis here or y-axis here, and they would create a shape like so. Place the letter from the graphs below in their table to match their functions. So what we have here is the different types of functions, and it's asking you to match them. So graph A clearly has a ramp shape. So from before, we said that this was an exponential function. Graph B, well, it has a sad shape or an N shape. So this would be a negative quadratic function. So we'll place B in quadratic function. Graph C, well, we can see that graph C fails our vertical line test as our vertical lines hit the curve a number of times. So therefore C would be not a function. And graph D, well, it creates a line, so graph D is a linear function. When graphing functions, there are 3 steps that you should take. You need a table with input values, the function and the output values. You need to list the coordinates. You need to graph the coordinates. We're going to look at this question as an example. So graph a function of f of x is equal to 2x squared minus x minus 3 in the domain minus 2 is less than or equal to x is less than or equal to 3. So again, if we remember our 3 steps, the first one we need to do is we need to get our table. We need our inputs, our function and our outputs in this table. We're going to look at now how to get the table, our input-output table, on the FX83GT Casio calculator. This is very useful if you find that working out the inputs and the output values is taking you some time. So what you need to do is you need to press menu and you need to press 3. And that gives you on your screen f of x. So this is where you're going to input your function. So what we do is our function is 2x squared. So we're going to press 2 and then we're going to press alpha and then the bracket, and that will give us our x. The squared button, we have minus x, again, alpha and the bracket to get our x, minus 3. What we're going to do then is we're going to press equals on our calculator. G of x comes in there. We're going to leave that blank. So just press equals again. Our range. So our domain of our function, it was from minus 2 to 3. So we're going to put our start value as minus 2. Our end value as 3. And yes, we want it to go up every single step. So each number at a time, minus 2, minus 1, 0. So we're going to press equals for the 1. Then our table comes up on our screen. So you see the left column that is labeled x, that's where our x values are, and they go from minus 2. You use the arrow to go down all the way to 3. And then on the right hand side, we have f of x, also known as y. So there are corresponding y values. Right, so here we have our question again, graph a function in the domain minus 2 to 3. And I now have my input table inserted. So if you see here, everywhere there was x in your function, we have subbed in our x value. So that's the table that we got from our calculator in our previous video there. So the calculator, it automatically inputted your x values and it gave you your y values. Notice at the end that we are left then with these coordinates. So our coordinate is minus 2, 7. So that's made up of our x value first and then our y value. Minus 1, 0, again, your x value first, then your y. 0, minus 3, 1, minus 2, 2, 3, 3, 12. So these are the coordinates that we are now going to plot. Right, so I've just inserted the axes there. So just be careful. There needs to be equal spacing in your axes. We'll label these. This is the x-axis as it goes across the page. This is our y-axis as it goes up the page. With your graphs, they should be in pencil. So do draw them in pencil. I'm just drawing it in red here because it's easier to see. So what we're going to do now is we're going to go about graphing our coordinates. So minus 2, 7 is the first one. So again, our coordinates, they go in the order x, y. So I go across to minus 2 and all the way up to 7. I go across to minus 1, 0. Then I have 0, minus 3, 1, minus 2, 2, 3, and 3, 12. Now what I'm going to do is I'm going to get a smooth line and try to join all of these. So please excuse a little shake in my hand there. You're trying to draw a continuous line. It's obviously going to be easier when it is not on a screen. So a smooth curve. We're not going from straight line to straight line. It should be a smooth curve through each point. And there we have our quadratic graph. So here's an exam style question. So it is giving you the function y is equal to 2 to the power of x. Now this is actually the second part of the question. So it told you the domain in the first part. So the domain is between the x values -3 and 3. Again, what I would do here is I would pause the video, give myself 5 minutes to try the question, and then resume and see if you got it correct. Okay, so now I have got my function of inputs on my calculator. So I'm just going to put this in my rough work. So I'm going to put in my functions table. So my inputs, I had -3, -2, -1, 0, 1, 2, and 3. And my y values then, according to my calculator, they are 0.125, 0.25, 0.5, 1, 2, 4, and 9. So my coordinates then, they're obviously made up of my x and my y. So I have -3, 0.125, -2, 0.25, -1, 0.5, 0, 1, 1, 2, 2, 4, and 3, 9. So now let's plot these. So I go across to -3 and up to 0.125. Obviously, it's very hard to tell where that is. So we're just going to make sure that it doesn't hit our x-axis. Same with the -2, 0.25. -1, we have 0.5, so go about halfway up. 0, 1. We have 1, 2 then. 2, 4. And 3, 9. Again, with our pencil then, as our graph should be in pencil, you're going to try to get a smooth line and to get all our points. Like so. So section 3 brings us to interpreting functions. So there are a number of things you need to be able to read off a graph. So you need to be able to read the max and min values of the function, where the graph is increasing and decreasing. Where graphs are intersecting, you need to know how to do this algebraically, and also reading off the graphs and finding the unknown coefficient. So the maximum value of the graph is the highest y value. The minimum value of the graph is the lowest y value. So if we look at the left-hand side here, the max value of the graph below is 3. So as you can see, the maximum value is here. If you see our labeled axes, you can see there's 2, there's 4, so it's halfway between, so it is 3. There's no minimum value of this function. There's only one high point. The minimum value of the function below is -4, so this is the right-hand side. So as you can see, the lowest point of the curve is -4. There is no maximum value of this function. So as you can see, these are both quadratic functions. This is a positive quadratic, and this is a negative quadratic functions. In order to have a function that would have a maximum and a minimum value, it would have to be an x-cubed function. And these aren't functions we tend to deal with at junior cycle. This function here, as you see, would have a max here and a min here. Right, what is the minimum value? So let's look at the blue function on the left. Again, we go to the lowest point of our curve, and it is where y is equal to -4. And again, we go to the lowest point of our curve here. Notice here that it isn't a whole number. So it's in between -2 and -3. So what here you have to do here is you have to make an estimate. So as you can see here, my box is broken up into 5 smaller boxes. So each of these tiny boxes is 0.2. Sorry, not 0.2, it's 0.2. So for example, the first box there is -2.2. As you can see, it's in between the first and the second box. So here I would be saying that y is equal to -2.3. Just notice here that these are min values, so they are the bottom of our curve. Right, so have a look at these two quadratic curves here, quadratic graphs. Take a second there and see, can you tell me what the max values of these would be? Okay, the max values, then I go to the peak of my curve. So I'm going to start with my graph on the left. And I'm going to go to the top of the curve there. And again, I'm going to draw a dotted line into my y-axis. So we can see it is slightly above 3. Again, the smaller boxes are 0.2s. So in this case here, I'm going to say that my max value is y is equal to 3.3. And on the right hand side here, I'm going to say my max value is where y is equal to 5. It's quite clear to see here as it cuts it at a whole number. Right, the next thing we'll look at is increasing and decreasing functions. So here I have a quadratic function, and we're looking at where this function is increasing and decreasing. To start off, I'm just going to split my function down the middle here. Okay, now you're going to read the function from left to right. So we're going to start looking at where it is decreasing. So as you can see, if we're reading left to right, this function starts off high and it ends low. So therefore it is decreasing from the x values of -1 to where there is a change in our quadratic, which if you notice here is 1.5. On the other hand, the function is increasing from 1.5 all the way up to 4. So as you see, as we move through them x values from 1.5 to 4, the y values are increasing. So have a look at this graph, pause for a minute or two, see if you can notice where it is increasing and decreasing. Right, again, I am going to split my graph down the center. So right here, we don't have a nice number guiding us, so we're going to look at our x-axis to see if we can figure out a bit more. So well, if 2 is there and it's 4 boxes, this must be 1. So where I have made my split must be 1.5. Right, the graph, if I'm reading left to right, again, the y values are going down. When x is less than 1.5. So the graph is decreasing when x is less than 1.5. As we said, the y values are going down whenever the x value is lower than 1.5. If we go from 1.5 onwards, our y values are increasing. So my graph is increasing when x is greater than 1.5. Intersecting graphs come up quite a lot throughout the junior cycle course. So we're going to have a look at some intersecting graphs and what questions they can ask us. So we have two functions below. F of x is equal to x plus 2. It is a linear function, and g of x is equal to x squared. It is a quadratic function. So firstly, let's look at the values where the two graphs intersect. So the x values where the two graphs intersect are -1 and 2. So they are the x values. But if they asked us for the coordinates where they intersect, we would have -1, because you go across to -1, 1, because you go up to 1, and you would have 2, 4. Right, where is g of x less than f of x? So this is saying, where is the quadratic function lower than or less than our linear function. Below it. Where is it below it? So let's look here. It is below our line between two x values. So between the x values we identified above, -1 and 2. So this can be written using notation. So we can write between x is equal to -1 and x is equal to 2, or you can write where x is greater than -1 and x is less than 2. If the symbols confuse you, you can just write the words. So don't get too bogged down by the symbols, as I understand this can be quite difficult for some students. Just know that it means where the curve is below the line. Right. Where is f of x less than 0? This means where is the line less than the x-axis? Or when is the line below the x-axis? So let's look here. There's our line, and this is where it intersects our x-axis at -2. So it is below our x-axis when x is less than -2, and it's written either using words or there's a symbol as well where x is less than -2. I would advise you pause for a second, have a look at this question below, give it a go, and then resume when you have made an attempt. Let's look at the graphs below. So f of x is x squared add 2x minus 3. So again, you should automatically know this is the quadratic. It has a U-shaped as its positive, and remember the positive is the happy face. X plus 3, then you should know that is a linear graph. What is the minimum value of f of x? So let's look here. The minimum value of my curve, my quadratic, is going to be where y is equal to -4. Between what values is f of x increasing? So here, where is it increasing? Again, for these ones, I like to cut my curve in two. Let's look at the point. Well, this point here is going to be -1. It's halfway between 0 and -1. So f of x is increasing. So when you move from left to right, the y values are increasing when x is greater than -1. Between what values is f of x decreasing? So on the other hand, our curve is decreasing, so my y values are going down. When x is less than -1. What are the values of x where f of x is equal to gx? Well, this value here will be -3. This value here, you may have to read down, will be 2. So where x is equal to -3, where x is equal to 2. Where is f of x less than g of x? So where is my curve below my line? And we know that it is in between these x values. So it was where x is less than 2 and where x is greater than -3. And our last question there, it says where is f of x less than 0? So where is f of x less than our x-axis? Let's have a look at our curve. So it's below there, and it's below from there. So this is where it is below the x-axis. So f of x is less than 0 between the values 1 and -3. If you'd like to give this question a go before we try it, go ahead. Right, the graph of the function f of x equal to 2x squared minus 6x at 4 is shown. Show using algebra the 2 points where it crosses the x-axis. So you can clearly read off the diagram the 2 points where it crosses the x-axis are 1 and 2. But we need to know how to do this using algebra, whether they didn't provide us with a graph or they're asking to show it.
The 2 points right across the x-axis, these can be known as something else. They can also be called the roots. So it may ask you for the roots of the quadratic. Okay, so let's look at our quadratic above. So we have 2x squared minus 6x add 4. Before I start, I see they all have a common factor. So I'm going to divide everything by 2. So I'll have x squared minus 3x add 2. Right, what we're going to do now is we're going to factorize this so that we can find the factors, and using the factors we can then use the roots. So we'll have x and x. We get our last number here and we look at the numbers that multiply together to give us 2. So that'll be 1 and 2. This plus sign here indicates that we're going to use the same sign for both, and we want to form minus 3. So we're going to have minus 2 and minus 1. Right, we're going to let our factors equal 0 then. So x minus 1 is equal to 0 and x minus 2 is equal to 0. We need to get our numbers on one side and our letters on the other. So we add 1 to both sides. So x is going to equal to 1 and x will equal 2. We've now shown the 2 points where it crosses the x-axis. The second part, it asks us to show using algebra the points where it crosses the y-axis. Again, we can clearly see from above that is where y is equal to 4. We need to know how to do this using algebra. So we have our function. We know that you can also call f of x y. So we're going to have y is equal to 2x squared minus 6x add 4. We also know that on the y-axis, x is equal to 0. What we're going to do is we're going to substitute 0 in everywhere we see x. So y is equal to 2 by 0 squared minus 6 by 0 add 4. Well, y is equal to, when we look here, 0 squared is 0, by 2 is 0, minus 6 by 0 is 0, so y is equal to 4. We're on to the last part of interpreting functions, so finding the value of an unknown coefficient. So you may be asked to find the unknown coefficient of a function given a graph of the function or some points of the function. If there's one unknown coefficient, you should sub in a point and solve the linear equation. Let's look at an example. So f of x is equal to 3x plus k. If f of 2 is equal to 11, find k. So we've f of x is equal to 3x plus k. So f of 2, wherever we have x, we're going to sub in 2. So we'll have 3 by 2 plus k. Now above, we were told that f of 2 is 11. So we can now rename our f of 2 11 and let that equal to, well, 3 by 2 is 6, add k. Let's get our numbers to one side and our letters on the other. So in the 6, the inverse operation is minus, so we take away 6 from both sides. 11 minus 6, k is equal to 5. Sometimes you'll be asked for 2 unknown coefficients. So if there are 2 unknown coefficients, you should sub in 2 points and use simultaneous equations to solve. So let's have a look at our example here. So our example, f of x is equal to x squared add bx add c. It contains the points 3, 0 and 1 minus 4. Find the values of b and c. So let's start with my first one here. So my point is 3, 0. So what I'm going to do is I'm going to sub in 3 for x. So f of 3 is equal to 3 squared add b by 3 add c. We know that the corresponding y value is 0. So I'm going to change this to 0. So 3 squared, 9, add 3b, add c is equal to 0. I'm going to set this up as a linear equation with my unknowns on one side and my number on the other. So I'll have 3b add c is equal to minus 9. Right, I'm going to do the same now for 1 minus 4. So f of 1 is equal to 1 squared, add b by 1, add c. That is 1, add b, add c. Again, I can replace my f of 1 with my y value, which is minus 4. We're going to get our letters on one side and our numbers on the other. So b add c is equal to minus 4 minus 1. So we have minus 5 is equal to b add c. Now we have our two linear equations. We have minus 9 is equal to 3b add c. And minus 5 is equal to b add c. I need to solve this with simultaneous equations. So I need to get rid of one of my unknowns. So I'm going to multiply my whole second line by minus 1. And that is going to give me 5 equals minus b add, minus c. Right. Now what I'm going to do is I'm going to write out my two equations again. So I have minus 9 equals 3b add c. 5 equals minus b minus c. So we have plus c minus c. Well, that is going to give you 0. We will then have 3b minus b is equal to minus 9 add 5. So 2b is going to equal, well, minus 9 add 5 is minus 4. B then is equal to minus 4 divided by 2, which is minus 2. How do we find C then? We're just going to sub B into one of our linear equations. So if I have minus 5 is equal to B add C, I know that B is minus 2. Minus 5 is equal to minus 2 add C. When my minus 2 goes over, it becomes a plus. So I have minus 5 plus 2 is equal to C. So my answer then, minus 5 add 2, minus 3 is equal to C. So just to go back up to our question, our function then will be f of x is equal to x squared minus 2x, because that's what our b is, minus 3. There are a few exam questions that are similar to the ones we were just looking at there, so interpreting graphs, and they're on the notes that are attached to this section. So have a go at them and see how you get on. For now, we're just going to keep moving just so you don't run out of time. Okay, so often in functions, they like to bring in real life questions, especially with project maths being at the forefront these days. So we're going to have a look at a exam style question and give that a go. So the function h of x below gives the height of a ball above the ground. H of x is equal to 6x minus x squared, where h of x is the height in meters and x is the time in seconds after the ball was sent into the air. Draw the graph of the function h of x is equal to 6x minus x squared on the axis below for x between 0 and 6. So here we have our function, here we have our domain. Remember, we're graphing a function. The first thing we need to do is we need to get our table. So our input and output table. So we're going to have x, y, and our coordinate. So you're going to get into your calculator now and figure them out. Right, so our x values then we have 0, 1, 2, 3, 4, 5, 6. And our y values we have 0, 5, 8, 9, 8, 5, and 0. So that gives us our coordinates 0, 0, 1, 5, 2, 8, 3, 9, 4, 8, 5, 5, and 6, 0. So let's plot these then. So we have 0, 0, 1, 5 across 1 up 5, 2, 8 across 2 up to 8, 3, 9 across 3 up to 9, 4, 8, 5, 5, and 6, 0. And then again, we should do our graphing in pencil. You're going to get your pencil and you're going to try to do a smooth line through all of these points. Hopefully yours will be a bit smoother than mine writing on the iPad, so that we can read off it then later. Okay, let's look at the questions they ask with regard to this graph. So it says, use your graph from A to answer the following questions. Part 1, find the maximum height reached by the golf ball. Well, we know that this maps the height of the ball. So the maximum height here, well, we were lucky, it was actually one of the points they gave us. So our maximum height here is where y is equal to 9. Right, it says estimate the number of seconds the ball was more than 3 meters above the ground. Right, so we know that our y values, our h of x or our y, is the height in meters. The question asks us the number of seconds the ball was more than 3 meters above the ground. So let's go to 3 meters. So we've drawn a dotted line out from 3 meters now. And we're going to look at this times it was at 3 meters. So let's look at this first one here. So to me that looks like halfway between 0 and 1. So that is 0.5 seconds. So at 0.5 seconds it was at 3 meters. And on the other side of our graph then, that to me looks like 5.3. So at 5.3 seconds, it was back at 3 meters. So to find the number of seconds it was more than 3 meters above the ground, we're going to get 5.3 seconds. We're going to take away the 0.5 seconds. And we're going to get and we are going to get 4.8. Right, the next one below, the graph below represents the flight of another ball. G of x is equal to ax minus x squared. This might start ringing bells, it's something we've already done. Unknown coefficient. And we know there's one unknown here. So what we need to do is we need to look at our graph and we need to see a point that we can plug in. This looks like a nice point to me here. So we have the point 1, 2. So g of x is equal to ax minus x squared. Let's plug in our point. So g of 1 is equal to a by 1 minus 1 squared. That is a minus 1. We know that the y value at that point is 2. So let's find a. We get all our numbers to one side. When the 1 goes over, it's going to become a positive. So a is equal to 3. So what we looked at today then was we looked at functions under 4 subheadings. So what is a function? So you should know now what a function is and how to test a graph to see if it is a function. Types of functions, so the 3 we looked at, we're looking at linear, exponential, and also quadratics. Interpreting functions, so max and min points in a function where a function is increasing and decreasing. We also looked at intersecting functions as well. And then real life functions. So these are questions that they often use to examine your knowledge of functions, where they've used a real life example and you have to interpret your function to get your answers. So I hope this session was helpful for you today, and I wish you all the best of luck in your study of junior cycle maths.